Greetings, Woodsians and School of Lifers and so on. This week we're talking about testing and acceptance, otherwise known as VV&A. As always, hang on one second. There we go. As always, there are links embedded in these slides, which are hosted directly on my website here in reveal.js. These links lead to other materials on my website and elsewhere. Go ahead and check them out at your convenience. I've been doing computer simulation for a long time. That's what inspired and drove my knowledge of business analysis. Many, you've heard all this before. So let's talk about testing. Test and acceptance, also known as verification, validation, and acceptance, it's not something you do when you get done and everything is built. You do it through the entire process, and you should be thinking about it from the get-go and incorporating and structuring everything you do with that in mind. And a lot of what I'll be talking about will be software centric. And let's face it, that's a lot of what BAs do today, but the ideas are totally general. So you've seen my framework. I'm not going into this. You're welcome to check out many other presentations where I talk about where it comes from, how it's used, and so on. Mostly what we're talking about now is how testing and VB&A is done all the way through and largely at the end, but structured throughout. So a major inspiration for my framework was an IV&B process we did for a Navy simulation using a simulation standard that this guy came up with. And it's probably overkill. I'm sure it is, and this guy had a wild personality, and a lot of people in big organizations used to fight with him. But the idea is sound, even if the details are a little overwrought. So if you do the work in this middle vertical line, for the system or simulation you're trying to develop, you develop a plan for how you're going to do the V&B, and then afterwards you do the V&B and report on what you learned. And around that, you do a plan for how you're going to accredit the thing and do the acceptance, and in the end you say what your results of the accreditation process were. So it's a two-layered envelope or wrapper around doing the actual development. So this link is a paraphrase of what Aristotle said. He said, tell them what you're going to tell them, and then tell them what you told them. And that's Will Smith having a character say roughly that in a movie. It's called 8 Pounds. It's a pretty interesting movie, and that was pre-slap Will Smith, so we all liked him then. So lessons from Six Sigma, here are a few things we learned. It's technically about reducing variation. That's what Six Sigma is at root. So fewer outcomes will be out of range and judged to be not acceptable. So what you're trying to do is do continuous improvement over time. A, so less samples fall out of range, and B, so hopefully you can tighten the range over time and improve quality and consistency. However, it's what you're really trying to do is prevent errors from happening in the first place and variation. So we know that 6 sigma is really 4.5 sigma, and it's kind of arbitrary and accepts that there is going to be about 1.5 sigma of random variation that can be controlled. So it probably makes sense in the context of Motorola's original processes, high volume processes, when they were developing this approach. But the ideas in general still apply. And what we're trying to do, the whole point of working through the framework I've created, iteratively and in a thorough, complete manner, is to make sure you get it right the first time and head off errors from happening. So we iterate between and within phases, and we track everything to make sure that we're always answering the intended use, that we're finding everything that's going on now, doing requirements that answer all the needs, including of the solution and methodologies, that the design ensures all the requirements, that all design elements are implemented, that everything is tested, and if all the tests pass, in theory, we accept it. So there are different kinds of testing that occur in each phase. The iterative testing in each phase is basically discover, data collect, document, review. And for example, in the conceptual model, that's the process for understanding what's going on now, that as to state the existing system, and so on. So that is a form of built-in test and acceptance that goes on in every phase. However, there are more specific things that happen. When we're doing data, we have to make sure it's correct and germane. So there's a well-known kind of aphorism or acronym, which is GAGO, which means garbage in, garbage out. If you don't have all the data, if the data is noisy or it's not the right data, or you leave things out, that's bad news, and things are not going to work out right. Requirements talk about what is needed. You have to make sure what the solution needs and all the users, organization, and stakeholders need. And there are two kinds of requirements. Functional requirements is what the system does, and non-functional is what the system is. And the design is where you create effective solutions that address the requirements, which in turn map to the conceptual model or the as-is state, if there is one, and that all maps to the intended use or the nature of the actual problem. Implementation maps back and want to make sure you have a solid design. You do local testing, debugging, and unit tests there. So the implementers do their own tests before they send it to outsiders to do other tests. And then the testing phase itself in implementation and test is the biggest situation where you're iterating between phases, test and implementation. So verification is doing a wide variety of tests. I'll go into those in some detail. And they're about whether the thing that you built works as you intended it to. And the validation means, does it address the actual problem that you've stated, and do experts think it really meets their need? And then accreditation is acceptance of the whole thing based on whatever standards you negotiated. Some will be explicit, some will be based on expert judgment. So I've talked about a lot of this already. I won't belabor it further. You can see some of the details here. And it's just what I said on the last slide. One thing I will say is validation results can be objective and subjective. And also that verification tests are most likely or able to be automated. Now, moving on. There's a traditional way of thinking about testing that's called the V model. So it works from the inside out, from lower to higher levels of abstraction. So as you're implementing items, you test them all individually. You do this with hardware components, software components, and everything else. And then when you put some more of them together into bigger groups, you do function tests that test the design, then the overall architecture, which is just higher level design, right? You test how all the pieces fit together as integration tests, and then you test the whole system against requirements. And requirements are written to address different levels, and that's your final acceptance. There's another way to think about testing that kind of differentiates in two dimensions: business versus technology, or technology or implementation, hardware, real world level, and what the organization needs. And then there's kind of team and people facing, and there's kind of product facing. So you've got automated stuff at a low level unit and component test. Manual testing does the high level exploratory scenario usability, user acceptance test, and alpha and beta test. And then a mix of those is functional tests against various spikes and prototypes and so on. And finally, you have different tools that test performance, load, security, and things like that. ILITI is basically talking about non-functional requirements that talk about modularity, reliability, scalability, and things like that often end in ILITI. So that's what that's about. Documentation can be part of testing. You have to make sure it's there. You shouldn't start working without at least some design direction, whether it's documented or not. But you can document and design at many different levels. Infrastructure, framework, and details is one level. I talked about a 3-level enterprise architecture framework or a way of thinking about things that has the application layer in the middle, which is the logic, kind of abstract, the technology layer, in which is hosted on the bottom, and on the top you have the business or organizational layer. And you kind of, in my universe, work from the middle up and down. So different teams can address or concentrate on different parts. There is a thing in Agile or Scrum that says you should do slicing vertically and not horizontally. But anybody who thinks this is a hard and fast rule never to be violated is basically not considering all the cases. Because I have developed tools that write software and generate systems, you definitely, as part of your work on horizontal areas as specific parts of what you do. And my understanding of that caused me to not get a job in an interview with somebody who had a nearer view of the whole thing. Good thing I'm not bitter about that. All right, so there are a lot of different kinds of tests. One kind of test or one family of tests had to do with coding style. So this means that things are done consistently, and naming conventions is very interesting. How this is done has changed a lot over time, especially from the days early on when languages like Fortran and others only allowed 8-character variable names at max. That means you had to do a lot with a little. For example, when I was at Westinghouse Simulators, the first letter talked about the physical quality or characteristic or property you were representing. Like P was for pressure, T was for temperature, W was for mass flow, that kind of thing. And then the next 3 letters were the 3 designator for the system. So there are about 50 different systems in a nuclear power plant. They all had their own abbreviation. Then within your model that you wrote, you had 4 more letters. There was a guy at Microsoft who came up with Hungarian notation, and that talked about the size and format of all the variables. Now that's kind of overcome because with code that's supposed to be portable, you cannot say for sure what your word sizes are going to be and so on. So now they have other guidelines for things you're supposed to do. Different languages are formatted differently. There's another one called, I can't remember, it was a weird simulation language by Wolverine Software, and it had a format that was a cross between Lisp and assembly language. Anyway, all languages have a different format, a way you're supposed to do stuff, in requirements, and you have to be aware of those. And organizations will often insist that people be consistent. They may go for clarity over efficiency. So I've talked about that in other presentations. Documentation standards may be set. And here's an important one. Code that if you're feeding, say, a function, something with inputs that can cause some kind of error, but you know the inputs are limited so that that error can never happen, it's okay not to test to prevent those errors. But you have to be aware of it, be explicit, and document what's going on in those cases. All right, unit tests are automated tests that look at specific blocks of code. They have some other libraries that only run when you're running the test. Every section of code may be subject to multiple tests. They're used in regression testing. So what you do is run the test, a whole bunch of them at a time, maybe hundreds, and see if anything broke. And they should be written by the coders. Once you're in a flow, it's really easy to write code and really easy to write the test at the same time. Piece of cake, actually. It's almost embarrassing. That's it. When people who demand 100% test coverage might be pushing the point too far, because why write a test for a one line function you know it's going to work? There are times when you don't have to do testing at all. It's better, really best for large projects with a lot of people and checking when interdependencies break down. So here's an example of code, and here's an example of unit test. They're really pretty simple. Basically, you call something to see if it exists independently or see if it produces the answer expected. And you can test it to see that it generates the expected errors and so on. So that's just one example from Java. There were interface tests. There are a bunch of different kinds of interfaces. You can send messages, you can do direct function calls either in stuff you've written or third-party stuff. You can have shared resources that multiple things access. You can have sensors interacting with the physical environment and also manipulating it. User interfaces allow humans to interact with the system and control it and understand it. Some can be spoofed, so there's ways, especially in interpreted languages, you can have stuff that'll jump in and substitute values for certain things that are going on. If you run it standalone, then you can also write test harnesses, and I'll explain that in a minute, or have external facilities that'll send test messages and receive responses. Just like other systems. Well, Postman is an example of that for APIs and microservices and whatnot. And compiler switches can, when you build something, you can build it in test mode, which generate some of its own faked external outputs or inputs, and you can also run it in production mode. So if you can imagine a giant system which has all these pieces, and I worked on this piece of a control system for a steel mill. I had to talk to external systems up and downstream. So this is the steel mill, scrapyard, melt shop, pouring ladles, caster, preheat furnace, that was me. Rolling mill, and then strappers, conveyors, shipping yard, and so on. They all have their control systems. They all talk to each other at various levels. They talk to lower levels, and they talk to higher levels. There's a traditional kind of 4-layer hierarchy of control systems. And as you can imagine, there has to be a lot of testing and negotiation to design these interfaces before the whole thing can work right. And then within those boxes, you might have all these internal communications going on. So this is a representation of what's in here. So this thing scales up and down. And I wrote a test harness that actually spoofs, or actually allows the internal system to run, and instead of talking with these actual external systems in both directions, it actually talks with my goofy test harness that's running on the same machine using the same communications protocols. And that was the interface for it, so I could manipulate all the values the system would respond to and could see all the messages going in and out. So there is local desktop debugging where you're figuring out what's going on. in your own little environment before you send it off to be integrated with the other stuff. The original developer should do this. You shouldn't fling stuff over the transom until you know it's as right as you can make it. There are different kinds of debugging tools and hardware software that exist. Really aid this process. I know when I got integrated development environments with built-in debugging, that really improved my productivity 1,000 times. You can see what's going on all over the machine to the lowest levels. If other people who didn't write the code are going to do this, their efforts will be greatly eased by you commenting code and providing documentation. In complex situations, especially real-time systems, you can't always use the most modern tools. You have to go old school and really figure out what's going on using some kind of Cro-Magnon method. And sometimes you can deduce what's going on simply by the output. So it's all about knowing what's going on. Sometimes you can do experiments in totally separate test beds. When you develop a piece, you probably don't have to test it again once it's integrated because it always works. You might have to test the interactions, but you know the calculations or function is correct inherently. This is an example shown of something I wrote in Orland Pascal, like 5, 6, 7 in there. Back in the early 90s, I guess mid-90s for this one. And they were for systems I put on Tech Alpha and fax machines that were actually implemented in both Fortran and C++. So whatever works, I had the concept, I had the calculations all right. There are a lot of ways to test. So let's talk about user interfaces. They can be manual or automated. There are special tools that allow that. You're trying to test things that it works, that it's usable, the users understand it, it looks consistent, follows the organization's color schemes and other standards and more. So UI should allow you to see all the information you need to perform an action, know where you are in the process, and take all the actions you need and recover from errors. And if you're going to automate that, there are tools for running different scripts and doing automated actions. And you should be thorough about this. You may need language experts to review international screens to make sure you get the language right. I know I was talking recently about how different kind of large language model translators may be good at this kind of thing. There are a few other kinds of random tests, so calculation tests, Smoke test is just to see, it's kind of a sanity test to make sure there's no obvious performance bottlenecks or other major screw-ups. Profiling sees what parts of the code are consuming what resources. There's standalone performance tests. I've talked about those already. Real-time tests make sure it runs fast enough for the use and answers things within a certain accepted time. There are recovery tests and long-term run tests. So a lot of different things. When you're doing microservices in a continuous integration, continuous deployment environment, they are often tested and released in a certain way. So a microservice is, there are there are functions, blocks of code that run on servers and external processes make requests of them. They do things inside and give answers, create side effects and so on. And people write these components and then they send them for testing. They'll do some desktop testing, then they'll go in the queue and they'll be advanced through all these environments. So if you can imagine, you have one environment for local testing, one environment for QA, one for user testing, and then if it passes all those, you send it to production. Not every function may exist in every environment. For example, when you're interacting with external hardware, so you'll set these things up in a way that makes sense, that allows you to test when you need to. And all the tests I talked about before can be done in these environments. There may be different specialized people running all the environments, and a release train manager will manage and control the entire thing. If errors are found in production, you might roll back to an older version, and there may be a hotfix environment that's separate for testing and forming little fixes kind of on the fly. Regression changes, testing tests to see whether any new change breaks something else. Alpha and beta testing is when you release less and then slightly more mature versions to potential customers and users, usually on a limited basis, and that allows you to do large-scale testing. It's really good for software that a ton of people use, like Microsoft operating systems that are used by millions, hundreds of millions, and maybe billions of people in every combination and permutation in a way they can never do at the home office. So then the businesses or whatever entity is accepting the program or your final work will do a final series of acceptance tests. And there are other tests that the industry or regulators may apply. So ultimately, what you need to do is make sure your organization survives, that you make profits, or at least don't lose money if you're a nonprofit, and you go ahead and maintain engagement, serve your customers, and so on. That's what it's all about. And that's all we have to say today. Any questions?
Yes, Robert. Towards the end of my most recent stint in software development, these automated and unit tests were in vogue. And I found that, though I definitely liked the idea of them, we were being pushed into these very opinionated frameworks that they tended to, the entire design looked to me like it was being led by the testing framework, or at least there was a tendency to go in that direction. I only spent a couple of years in that environment, but I was wondering have you found a good way to manage that, or do you think that's a good thing, or what are your thoughts about that?
Well, like everything, it's a balance. There are a lot of people who would say they don't test at all, right? And there are reasons for that. When I did a sole practitioner project, and they had to integrate with several other systems, but I was basically in charge of all the parts. I didn't test. And it was before test-driven development and unit tests came up anyway. One of the guys who gave the talk Agilist that I often refer to, he helped write the Agile Manifesto circa 99, 2000. He doesn't test. It's
Yes,
like
I watched that.
everything.
I
Too
went and
much of
watched that
a
video.
good thing is bad. So you want to be in charge of it and have not have it be in charge of you. What were you saying? Sorry.
Oh, sorry. Yeah, I just was saying I did go and watch that video. I forget the guy's name, but the Agile founder who was commenting about where Agile had evolved to and the fact that he doesn't test.
Yeah, it's like Agile kind of ain't the world, and you have to understand what it is, what problem it was trying to address, and get to the root of that. There are many analogies to that. For example, the Malcolm Baldrige Quality Awards, people have gone crazy, doing everything to try to win these awards, and they go wild trying to implement all these processes, and finally they realize the processes are running them and they're not running the process. You want things to be as light and useful as possible to get the best bang for the buck. Do what you need to, but no more. And I include all these things here just to be thorough.
Yeah.
So you know what all the possibilities are.
Yeah, I think there's a need for discernment in well, and this is no exception to everything else, but on this topic in particular, the discernment needs to be between things like as you said, a one-line function. In many cases, when we write a one-line function, we're just renaming something really for convenience. We're, like maybe you're converting Fahrenheit to Celsius, just as a simple example. So you're taking those two operations and just packaging them under one name. You don't need to test that. I mean, you need to review it and make sure you wrote the formula correctly. So maybe you need a second pair of eyes to make sure you didn't go crazy and do the wrong thing. But after a review and you confirm you put the right formula in, that's not something to test, because that's a definitional thing. Whereas the things that you want to test are things that have interactions, things that are not definitional. They have certain interactions that might do things you didn't anticipate, and so forth. Yeah, I guess I don't have a question, but that's
exactly,
I think that's that's a general trend with any framework. When people get too attached to the framework, they start offloading their discernment into the framework, and I guess, and like you said, they're letting the framework run them instead of them running the framework.
Yeah, that's why even in my framework, overarching framework for numinal this, I never mean to say that you do this, you do this, you do that, you do that, and there's a formalized fixed way to do it. It's always need to be as light as possible, sized appropriately to the effort. It's give you situational awareness and guidance, and not meant to be some heavy deterministic thing you're supposed to do. But it really tells the same story the IIBA tells in the BABOK, which I always say. It's basically a restatement of their process, from a different point of view that I think is easier to follow. But one thing the IIBA always says is, we do not want to be prescriptive. And they're so hardcore about that, I think almost to a fault, I think absolutely to a fault, that the people writing the book aren't allowed to give you even examples. They leave it all open-ended. And it's like, people need different stories. And they need examples. And you have to understand really the underlying thing, but frameworks exist to get you started. So it's like I said at the beginning of this series, I could teach you to do the basic step in my favorite dance in 5 minutes. And you can go to any dance in the world where they're playing that music and people know what dance you're doing. You can dance all night with your sweetie and everyone else in the room. You can have a great time. You can also do the basic 50 different ways, and you can also spend a lifetime learning how to do things better, do more, integrate with other dances, do variations, and really just go wild, right? And the point is, with the framework, it's not meant to give you everything you can do. It's a place to start, and it's a place to let you get in and see what it all means. And it's really your understanding of how to do all this stuff is iterative, just like everything else. You and I and Chad have been in this game a long time, so we've kind of passed through into understanding the context and knowing where all this came from and why it's there and how to interpret it, and aren't so confused by people's hard prescriptions and requirements on things. The benefit of being older, right?
Right. Yeah, those are good points. I agree with all of that.
All right. Anything else? Pleasure as always to have you with me. I'm sure everyone else appreciates it too. And have a groovy day.